yesterday I had an interview that I think went okay. I'm not 100% sure, but I think it went okay. And like job interview. It included a coding exercise, and there were some technical difficulties with the tools we were using that slowed me down and meant I didn't get to the finish line, but I was able to demonstrate my thought processes, and I think I handled myself pretty well in that whole situation. But I'm going to talk about the technical difficulties eventually. They were nothing to do with the company I was interviewing for at all. I'm not going to talk about which company it was, and I'm going to change the exercise a bit so that I'm not handing a cheat sheet to anyone else they may want to interview later, or anyone else who wants to use the same interview problem. But I found it interesting. So I'm going to do a variation on that, which be a little awkward to directly use as a cheat. This is maybe going to give you some ideas of how to solve it yourself, but nothing you could just like copy and paste. To be honest, I've actually had to put a little restraint into not just like throwing myself into this off stream, because as soon as I realized this would be a good like change up the pace of things kind of stream, I really wanted to do it on stream, so I had to save it for streaming. And the idea here is I'm going to put the resulting code on my website. I'm going to do the regular glue integration so that you can easily download and run it yourself. That's the idea. So I'm going to hit this button, and look at what I'm broadcasting in full screen. Wonderful. Wunderbar. Okay. Yeah. So we've covered the context. It was a good exercise. It was a good interview. I liked the guy who interviewed me. He seemed like a very decent person, and he actually helped me with the tooling issues. Alright, so that's that. What is the problem definition here? So the idea is that you have a board of letters in some configuration. And again, I'm making a variation on this. So I'll describe my variation rather than the original problem. So where do I want to save this? I'll just alright, so you have a board, and it's in a text format like this, and it might have some empty lines, and it's going to have some letters in here. I'll just caps like this. And I'm putting some gaps in here to really emphasize the challenges of the problem definition as I've described it. I'm still in uppercase. Here we go. So let's say that you have a board like this. And the problem that you're supposed to solve here. Some days I'm just getting stuff out of my throat all day. Ridiculous. So, the goal is to write a board contains function that takes the board as the first parameter and a word as the second parameter and returns a Boolean. I think the syntax is this. I haven't done hinted Python in a little minute, so bear with me. So here's some type hinted Python that I hopefully got the syntax right on the return type. This is going to return true or false. And our definition of whether it contains a word is whether you can start on any letter and then with only horizontal and vertical moves, no diagonal, only horizontal and vertical moves, can you start from a letter and move around and then complete the word. So, for example, and if the word was N-E-J-E-K, you could do that by going N-E-J-E-K. You can't cross spaces. You can't go off the board. But you can do any kinds of moves and you can start from anywhere. And if you're able to do that, then the board contains the word. And if not, the board doesn't contain the word. Now, I'm not going to try to recreate the interview environment here. I want to do something that's much more amenable to this medium and frankly quite a lot more fun and closer to a regular day at work if I was employed. What I want to do is I want to create a very bulletproof, definitely correct version of this and then use that for property testing so I can try a bunch of different ways of solving this problem and benchmark them and compare them in terms of elegance and speed. Because some solutions will be more elegant than others. And some will be faster and some will be slower. And being able to confirm that they're all correct, have that as the level playing field, and then demonstrate which ones have which advantages is very cool. And the kind of thing that is worth doing when you have the time to do it. You often don't in a professional environment. You have to pick one thing that's good enough and write it that way. This is me taking advantage of my privilege of running my own streams, setting my own rules. So what we're going to do here is we're going to start by TDDing this. We're going to build up a suite of manual tests to validate that kind of a potentially naive and slow implementation that is hard to get wrong is correct. And once we have our reference implementation, then we can start doing the comparative stuff and factoring this into multiple files. At the end, I'm going to host all of this code on my own website. So, right now, this will not work. It's at least returning the correct type, but it's not going to get correct results for everything. Alright, manual tests, and this will be something where we provide a function. I'm not going to try to get a type signature for the function here, but it's going to be some implementation of board contains. And we are going to test it in a variety of situations. Alright. Not board contains. And there's no way to get like 5 H's in a row. Like, some of these are going to be hard to manually assess while we're making our manual tests. But I'm not sure there are any H's in here. There aren't. So here's a good start. And when run as a script, we are going to run the manual tests on our reference implementation. This will eventually do more things that are more conditional on what parameters you're putting in, but not yet. Right now, this is pretty much just like as simple as is appropriate for our current scale. So we run the manual tests on board contains, which is our reference implementation that is needing to be exercised. And I think I need to, like, how do I, is it update alternatives? I'm tired of the command Python not working and Python 3 does. Oh, but I want this to work on a variety of platforms, so okay. I'll just edit my settings. There we go. And to fully encapsulate this, we're going to remove that and put it in here. I'm going to keep hitting comma R, which is my shortcut for testing, because I'm used to using PyTest in this realm. But here for portability, it's just language level assertions. Which are not being recompiled to actually be test assertions within the PyTest framework. Alright. So, I want to have something that will force these tests to fail. But be extremely simple. The word is just U. We have a few U's in here. It doesn't require any navigation. And that's probably the bare minimum change we can make to our test. That will require a bare minimum amount of change to the reference implementation to fulfill it. So, honestly, I could do return word in board. Likewise, when something is in a row, like this VEB from left to right, that's another thing where that definitely should pass. But we also want to make sure that backwards works too, which it currently doesn't. And the laziest way to make that change would be return word in board or reverse word in board. I think that will work on strings. I'm not entirely sure. That's right. Okay. That still doesn't work. But this might as well be a good opportunity to start making this a pretty major leap in realness in the implementation. So, line in board. Char in. So we need to do something per character in the board. I think there's no tiny change I can do here, actually. So here's what we're going to do. And just for the sake of demonstration, this is going to completely break. But you can actually get a readout. Oh, I see. So I need to break this down into that's okay. Some things support lines, some things don't, I think. Like files support line iteration. I've been doing enough stuff in Rust now that I have a little blend of the two in my head. So I might just do this. And this is why some, like, a little bit of naive printing while you're nailing something down is quite good. Okay, so for x char in enumerate line. X, Y, char. Okay. Okay, I know what I'm going to do. Position, pause to char is going to be a dictionary. Pause to char. So positions are tuples of x, y, and there we go. So let's verify that that builds up a reasonable lookup table. Wonderful. Now, we have a lot of spaces in here. And I'm going to filter those out. That's essentially positions that don't exist as far as we care. And now this is a bit smaller. You'll notice that all of these are printing twice because we're hitting things in the test suite. That don't work yet. So I'm going to move that test to go first so we always get one print. That's going to be a bit clearer. You'll notice that that's half the size of the previous one. So we reduce the output size of debugging by not putting spaces in our alternate representation of the board, our internal representation of the board, and now we're just not printing it twice. So this is much easier to work with. All right. So now we have our lookup table. We're going to need to do some sort of recursion here. This is all of a sudden basically forcing a complete implementation. We have enough tests that all of a sudden this is very hard to fake with something that's not quite the genuine article. So, I'm going to make a recursive function where board contains creates the lookup table, then passes that into the recursive function along with some parameters. Maybe call that mapping instead of pause to char. Oh, that's okay. Pause to char. It's nice to have the same names for things and have them be somewhat descriptive. So we don't pass the original board to the board text to the recursive function. It's not useful. It's going to be using this as a lookup table. Okay. So, what else do we need to pass in here? Well, we need to pass in the word, but it's not going to be the whole word. It's whatever's remaining. So I'm going to call that remaining. I'm sorry, I just had like a toenail issue here. Okay. So, the remaining thing left to solve, and I'll do a starting from as a position that we check around. Okay. starting from not in pause to char, return false. Alright? So if we try to start from an invalid position, for example, one of the spaces, that will fail. Or, I should say, it will correctly say, there's no future through here. This is not a possible state. I'm going to disconnect from Wi-Fi before I forget. I don't need to be connected two ways. Alright. So that checks that we're in a valid part of the board. And the next thing that we want to check is if pause to char starting from not equals remaining 0. So if it's not in the board, we early out. If the thing that we're starting from doesn't match the first character of what's remaining, we'd be allowed. Oh, there's another case that I need to cover before anything else. If not remaining, return true. So an empty string should succeed. So no reason to print the mapping, but we are going to I know how we're going to do this. Any is a thing in the Python language. So I'm going to do a generator expression in here. If any starting position gets us a success, then there was a success. If not, that's a failure. So we're checking every starting position, and from there it's recursive. To char. Word starting, and then position for position in pause to char dot keys. And that has no assertion errors. Board contains blank. That works. Then we still have a possible none case here, so I'm going to return false. Slight syntax issue there, such as life. All right. So here's where the rubber is going to meet the road with recursion. Neighbors. Here, I'll make a comment for myself. At this point, we know that remaining 0 matches starting from. There's one other requirement I forgot to mention. We will get to it as an extension. But to give you a preview, the correct version of this will not allow going over a letter that we've already gone over before. That will be an important requirement, and it will change how this has to be implemented. So x, y equals pulse, unpack that. Neighbors is going to be x minus 1, y, x plus 1, y, x, y minus 1, and finally x, y plus 1. And those are the 4 potential positions that are, police going by. The 4 potential positions that may or may not be valid positions on the board, may or may not have the next letter we're looking for. These are the places that we need to check, because maybe. So for n, maybe? Oh, this needs to be starting from. And this can be position in neighbors. If underscore board. I can do another any here, actually. Return any board contains to char never needs to change. This is carried throughout the computation. Remaining, we take one character off and continue. And then position for position in neighbors. And I'm going to break this into multiple lines for the sake of readability. So we do attempt to recurse here. I think that there's a potential for an infinite loop, because we haven't yet done the you can't traverse twice rule. I don't know how realistic that risk is. I don't want to think about it too hard because it's not super relevant when we're going to change this anyways. So we passed that assertion. We're passing all of our tests so far. I will be right back. Well, I'm definitely not going to go into detail on this, but I really do wish that my medications did not have the side effect of making the bathroom my second home. That'd be a wonderful world. We don't live there. I must endure. So I want to come up with a situation here where, yeah, I think I've convinced myself that this can't infinite loop, because everything it tries that doesn't work, it'll early out. But I want to come up with a test case that can only be fulfilled by crossing over letters we've already crossed. So perhaps X, N, W, E. I do want to confirm first, actually, that we can travel vertically, and the system understands that. X, N, W, E. So it gets that correct. I'm going to name all these test cases. Linear left to right. Linear right to left. Characters that aren't present. Character that is present. I would like to have some intention encoded in these. So I can make this a little longer by going in a different direction afterwards. So B, E, E, maybe. Multiple direction changes. I expect this to work with current code. And it does. It's able to understand that. So, what would be something that could not be done without a check against retraversal? Is, I think, only one R. Yes. So if I do JR, 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 now we're finally getting a test. Cannot retraverse previously used positions. Here's where I'm expecting, there we go. And it's very nice to have these like names of the intent of the test on here. All right. So this means that we need to track something else the entire way through, and it needs to be tracked correctly as we work. What positions can we use? And one of the ways that you can do this is by making a copy of position to char, where you're just removing the one that you just checked. So here's what I'm going to do real quick. You know what? I'll do it in a separate terminal. side by side. Alright, help dict. Because I want to make a copy. Here we go. Copy, and it produces a shell copy of D. It does return the removed thing rather than returning self. Oh, I might as well mark this. Right now, we are working on the first implementation. So I know that there's a lot of people on here who are not going to necessarily be technically inclined. They just like watching these things come together. So my thinking is, I want to create a copy of this. If I can type correctly. I want to create a copy of this that is only slightly changed to not include starting from. I'll make a little helper function for this. Def board, maybe mapping without pose to char and position. I don't need to do this as a separate function actually. For some reason I briefly had it in my head that I would need to do a different one per item in these lines. And because of the API for Python dictionaries, that's awkward to do in a very inline way. But every single thing that we are going to try here, what are we removing? We're actually removing starting from. And it's going to be the same for each of the neighbor positions that we check. Alright, so new mapping equals pause to char dot copy. New mapping dot pop So now we know that new mapping is a pause to char where it's no longer valid to traverse the thing that we just traversed. We can pass that into board contains. Need to delete that. We no longer need a separate function for it. There we go. We cannot retraverse previous positions. And I want to do a similar one for a larger cycle. Alright, so for example, JREAJ. And the pattern here, we start here, go down here, go down here, well, to the right, A. That is the only way to get the first bit here, the JREA, because we know there's only the one R, right? So it has to go through here, and then it would have to retraverse. And the reason why I have a separate test here, I expect it to already pass with this implementation, right? I expect that this will not require any code changes and we're already there. The reason why I have a test for it though is that an implementation could be almost right if it was only checking like you hadn't gone back and forth one time And that implementation would catch some really basic stuff like this JR test. It would catch that kind of thing, where you're just going back and forth immediately in place. You only need to track the last thing that you've been to. But that kind of implementation would not be correct. So this cycling test is to make sure that we have coverage there. So that stuff that we visited a while ago, a couple steps ago, that's still considered off limits. Tests continue to pass. And I kind of want to confirm that we can't cross gaps. So maybe DENMMN, which could only be fulfilled by crossing that gap. Another thing that this implementation shouldn't have this problem, but it's good to have a well-rounded test suite. At this point, I'm very confident that my reference implementation is correct. What I'd like to do is I would like to move that to its own file and have that be imported by basically I'll keep this from here to the bottom of the file. I'm going to keep that in main.py and start moving implementations into their own files that we import. From .reference from .import reference maybe, and then reference.board contains with no known parent package. Okay. Is it just this? Oh, I see. It's because I have board contains directly referenced all of these places instead of using the provided function. That's a lot more concise. Now we're back to working. I'm not sure if I need this init.py. I kind of solved the problem that I was having. But reference.py is now looking good. And we can start to consider improving the documentation, that kind of thing. I'll leave the names the same here. I'll also add the property testing feature, which won't give us anything. What it does, here's what property testing does. It says, I have some sort of invariant that I want to test for that might be very simple, and I want to test that remains true on a large variety of random inputs. So, one of the classic ways that you can do that, and the way that I'm going to do here, is the test is literally, does the thing we're testing give the same result as the reference implementation? Property test fn. Now, by definition, unless there's some sort of like mutability, non-idempotence, whatever going on, the reference will always give the same result as itself. So, I want to create a bunch of random test cases. And you know what? While we're working on this, just to nail this home, I'm going to make both of these plural. I want to be able to have this small enough that I can print debug briefly and then move on. Alright, because I want to check that the random test cases work. Alright. I would at some point like for the board to also be randomly generated, but here I go with let's. Letters equals set board, so that you can put any iterable into a set and it will give you a set where each item out of the iterable is present in the set. So this will also contain spaces and new lines. So help set. Discard is what we're looking for. Letters dot discard space and backslash. And before we even do this, I want to double check that letter's the same. I don't know if I actually need to do that. It might be helpful to have this be a little wider, actually. Just uppercase alphanumeric characters, which I know that there's tools in here. ASCII uppercase. Port string. Letters equals string.ascii uppercase. So here's a thing about Python that is worth knowing if you've ever got a large project that's somewhat performance sensitive, doing like a loop of many things. Accessing globals from within a function is far more expensive than accessing locals within a function. So it's extremely common advice, for very good reason, and it also shortens things, to have a local copy of whatever global thing you need. Now the help function in Python, you can provide a string instead of, like an expression, and it will do the imports for you. This is what we need. There's a lot of things here. But I think I know the correct way to do this. There's a couple different ways to do this, and I think this is what I want, in combination with number of letters being random as well. Alright, so word size equals random dot. I'll get the import here in a second, but rand int zero and maximum 50. That's going to make more sense on a larger sample size. All right. Word equals dot join, and this is going to be random dot choice letters. For underscore in range word size. The reason why I do this is that a lot of the options here that are provided directly by the random module, they don't allow for the same letter to come up twice. So this is us making sure that that can happen. Okay, so here are some random words. 50 might be a bit excessive. We do definitely want to get small ones as well. So we are successfully generating random words. And instead of printing them, we're going to assert that fn board word is equivalent to reference.board contains board word, and we're going to use the word as a assertion failure message. So if it fails, we see the word that was the failure point. Now obviously, the reference implementation is always equal to itself. But the thing is, that's going to be very helpful when we try some more adventurous things. And we can literally just bump that number up and wait a little while. And feel pretty confident that the thing that we're testing matches the reference implementation. So that's property testing in a nutshell. Rather than write individual test cases, we have a test case generator and a way to make use of that generator. And the most common kind of property test is like this, where you're saying like, does this match another approach to solve the problem? Are they getting equivalent answers? Some amount of manual testing is pretty much always useful. It's why I have some. It's why I use that to develop my confidence in the reference implementation. And not all property testing is compare against a reference implementation. Some of it is like, you have some other invariant that you need to make sure is always true. Like, this doesn't have an exception, or a number is within this range, that kind of thing. You can even have like statistical property tests where you're like, is this randomly distributed within a distribution evenly? Is it, or testing whether it's enough of a normal, like Gaussian curve of probability. And that can be very useful for especially like random number generators. There's a lot of different ways to generate random numbers in a computer, but there's a limit to how random randomness can be in a deterministic system. So you need to be able to assess the quality of a random number generator somehow, and property testing can be really, really useful for assessing the quality of a random number generator. So we have property testing. I need to, you know what? I will do the benchmark stuff first, and then alternative implementations. So we can start comparing the benchmarks of one thing against another. I will be right back again. And of course, the snack doesn't hurt. Okay. So now I need to, oh, it's got no Firefox on it. There we go. I can never remember what's built into Python as far as benchmarks and what needs to be provided. This is literally what I do when I have a thing I've done before, but I've got a gap in my memory. So, here's where I'm running into a bit of a dilemma. I want to keep this as vanilla as possible. I want it to require no third-party libraries. Idea being, I'm going to have this be a downloadable thing in a very simple format. It should work with the Python installation you already have, if you have one, and not require a system installation of some particular benchmarking tool. And it's a shame because a third-party tool can make the output better and guard against certain potential errors in benchmarking. I just poured beef jerky all over myself. It's very annoying. If I still had a dog, he'd be all over that. So the portability aspect is in competition with, how would I do this if this was a job? We don't eat silica in this household. Mm. All right. So how do we programmatically use the time-it module? Oh, here we go. The documentation of this is always weird because a bunch of this is on a class instead of, like, there's these brief mentions of module level stuff. It's not directly documented. This is all about making some sort of implicit global timer. Alright, so there's a statement, setup. That's what we need. Which comes first in this? I wonder. Alright. We need the time-it module. Timeit.timeit. And I'm going to assume that the statement is the first argument. So what are we going to be timing here? Then board. Do we need any setup beyond that? I want to see if this works. Just as is. It would be wonderful if the locals were available there. So here's what I'll do. I think the globals approach makes more sense, but I can't use timeit.timeit that way. I'd have to make a timer. and run time it on it. Oh, this is a top level function. I was completely missing that earlier. I don't know why I didn't see it. Globals equals this is going to be fn n and board. I'll just I'll leave that there. Board. Okay. I probably should have reduced the amount of property testing that I'm doing here. Well, hello! The tourist from yesterday. Not yesterday. Wednesday. How are you doing? And of course I need a third argument here. So I'm going to reduce the amount of property testing I do here for the time being. XKU JED. So that should find this sequence XKUJED within the board, and we use that as our benchmark. I'm doing pretty good. I'm doing pretty good, honestly. I had a job interview yesterday that I felt went really well overall. Oh, that prints nothing. Anyways. Alright, so I had a job interview yesterday. There was a coding exercise. It was very interesting. I think it would have been pretty fun if there wasn't like the time pressure and some tool issues. So that's why I'm doing what I'm doing today. I'm making a variation on the exercise, and I'm doing it as a variation to make it harder, actually, and not something that easily lends itself to someone like using this to cheat for any kind of job interview. I don't want to set up this company for people having solutions just like to copy and paste. So I've got this exercise where the entire point is like you're checking whether a word is contained in the board. Whether you can make that word by starting at some position and then doing horizontal and vertical movements in valid spaces until you've completed the word. So something like the word drive would not be present in here, because there's only one R in this board, and you can't like start at a D and get to the R. You can also only go through each letter once. Okay. This is going to be bench time and print benchmarking took. I'll do this as an S string. I believe this is in seconds. Alright. Precise, this executes the setup statement once and then returns the time it takes to execute the main statement a number of times as float seconds if using the default timer. Yeah, up, down, left, and right. Excuse me. Alright, so our reference implementation is, it takes 24.4 seconds to run it, what is this, 1,000,000 times? Alright. Thousands, or ones, thousands, millions. Okay, 1,000,000 times. Oh, it's the same here, too. So 1,000,000 executions took 24.4 seconds for a reference implementation. Everything after this is about making other ways to solve the problem that are equally correct but potentially faster. I'm going to pull out these multiple definitions of board. I'm going to make a global variable here that I just reused in a couple places. Board equals, I'll delete this and put it here. Come on, then. There we go. And board equals board in each of these places. I will also want to bump up the property testing amount once again, now that we are going to make some real functions, or some real alternative implementations that need to be property tested against the reference implementation. And I'll maybe pull this out. Property test iterations equals, how about 80,000? So right now it's testing if the reference implementation is equal to itself, which is why I didn't want to waste too much time running that, because of course it's going to give the same results as itself. When I was deleting those, I think I might have been using the markers. I just kind of like muscle memoried it. And I use markers pretty often, so yeah, I probably did. So here's our reference implementation, which is pretty straightforward. There's something I want to see if it makes a difference, and so ref with memo Alright, so there are built-in tools in the Python standard library. I think it's func tools, where, yeah, you can have an LRU cache. It's just built into the language. Yeah, here we go. I'm going to start with my reference implementation and have the only difference be that I memoize certain things. Alright, import from functools, import LRU cache. Idea being, I don't need to qualify this where I use it. So I'm going to make a separate function, create mapping, word is a string, dict, stir, and this is a tuple. I'm not going to look up how to type that. So I'm going to put this stuff in here. Create mapping board. Alright, we do need to return this. On its own, this is clearly going to create more overhead by doing stuff across a function call boundary, but what if we cache it? Import ref with memo. Here's what we're going to test. Ref with memo. We're going to test that against the reference implementation and the manual tests. So if anything broke, we'll know. Yeah, I feel like everyone uses a different little personal subset of Vim that is just a lifesaver for the way that they think, but it's different from one person to another. Oh, wow. Yeah, Python standard library is very batteries included, also gerbil feeders just in case. For real, for real. It's definitely affected my standards for other languages. So, just caching the pre-compute conversion of a board string into a dictionary of positions to characters, it's work we'd have to do anyways, but now we have a cache in front of it. That has significantly cut down the execution time. We still get the same results for either implementation, but the cache-friendly version took 15.35 seconds instead of 24.2, 24.4. So that was immediately a huge win. And we might be able to take that a little further. Now, I will point out the thing you have to be a little cautious about with benchmarks is that they don't always match real-world use cases, and something like an LRU cache of the one test case may provide a huge benefit in benchmarks, but not in real code, or real consumer code. Yeah, that's another thing. I would agree with that. Like, it's about the same level of efficiency for everyone that I've seen, and yet getting to nirvana by very different paths, which is fascinating. And it also makes it very funny when someone's like, when you watch someone working and they're not using your thing where you know that it could be better in this way that you always do, and no matter how competent the other person is, and you know it, and they're doing stuff that you think is magic, but then they get to this one spot, and it's like watching someone who's kind of like Googling to find Google or something. You know, one of these like real consumer computer literacy anti-patterns. You're just like, oh, goddess, give me strength. So, all right. This board contains, I'm going to try LRU caching it just naively and seeing if that makes a positive or negative difference. This is not really configured in such a way to be like intentionally LRU cache friendly. There are architectural decisions you could probably make to be really smart about caching here. And I'm not. Unhashable type dict. That's because we're passing this in. That makes sense. Alright. That makes sense. So we might not be able to do that without some real differences to the architecture here. Without going down a super deep rabbit hole, Python has a definition of hashing that's very much built around its use in hash tables. Hashability is not like you'd think of with like MD5 or SHA-1. It's actually just about like, is this an immutable object that can be reduced to a number for quick comparison reasons? And LRU cache relies on that, and it's also something that is a requirement for dictionary keys. And I wouldn't be surprised if the implementation of LRU cache was using a tuple of arguments as a dictionary key. Like, that it's using a dictionary under the hood. The function arguments are being treated as a collective key into that dictionary cache. That is my instinct about how this would be implemented and why hashability is so necessary. There's also the argument that, like, on a real, like, understanding the why level, you can't really cache around something that's super mutable, because the cache results may not be valid if the underlying mutable object changes. So if this was an immutable dictionary, yeah, maybe. I'm going to be right back. There may be a way to make this work. Okay, so I think it's time for me to flip something here. I've got this main.py where, can I type? Good grief. Alright, I got this main.py that imports various other things and has all of the benchmarking stuff and the testing. And what I would like to do is I would actually like to flip this around where this is a suite of tools that are then imported into files like this. And we have the if name equals main construct. So I'm going to do a couple things here. So now these are reusable pieces. And very importantly, I want to have a full suite function that takes whatever our implementation is and does manual tests, property tests, and benchmarking. Okay. We still have to import the reference implementation for the manual testing, but I know that it's controversial to move an import out of the top level, but I would like to do that here in order to proactively prevent a import cycle. This is going to be a lazy import. It's quite important. Alright, so I'm probably going to move this to suite.py. Yes, exactly. I want to use this from reference. Have everything that we're doing have an if name equals main, import suite, suite.full suite, Word contains. Alright. And I expect this will actually work just fine. So now each of these implementation files can do all the work that it needs to be the specific set of tests and benchmarks for itself. So that takes about as long as it used to. That's completely expected. It's so weird to be doing this not as a Git repository, by the way. I have I have so much instinct that I'm having to push down to like get commit every once in a while when I have the you get a feel for when it's a good milestone, a good save point to nail things down. Alright, cool. This is coming right along. So what else do we want to do here? What I would kind of like to do is do an LRU of board string to lines, or board string X and Y as the arguments, and have that return the character there. And that will be LRUable. I'm curious if that's going to work out well. So this is going to be LRU indexing .py. Okay, so instead of creating an upfront mapping, I'm going to pass the board string here. Nice. Yeah, I probably should have more Git related keyboard shortcuts in Vim. Because often what I'll do is I'll just like Control Z to background the Vim process, and then I'll do whatever I want on the command line, and then FG to get back to what I'm doing. And you'll see me do that all the time. So one of these days I need to really think about what Git related shortcuts would I want, and what's stopping me from using them. Because there's always a place for that more involved, like, tinkering and checking. But maybe I can make that place smaller. That's true. It is a little easier to tell what's going on doing stuff from a command line while Vim is suspended. That's true. Alright, so what we're gonna need here is def index board, given a board string, an X and a Y, and if I was in Rust, I would be returning an option type here. So what I will return from this, once again, I don't really want to import like stuff from the typing module in order to do anything, but this is going to be a character or none. So we will catch any index problems and bubble them up. This is going to use the LRU cache. Okay. Lines equals board dot split on new lines. And if y is less than 0, no, if y in range lines and x in range I'll do this in 2 separate lines here. If x in range lines y, return lines y x. Now this is a little risky for production code, not in the sense that it will fail in risky ways, but actually because we're redoing the work for splitting the board every time, and that itself may be worth LRU caching. But let's try just this, first of all. Okay. So, post char if if index board starting from is not remaining 0. All right. Now I think I know something that's going to go wrong here. Alrighty. Because we were using post to char as our tracking for stuff that we'd already visited. So we need to track what we visited somehow. Visited or I'll do that up front actually. I'm a little distracted by all the different directions my brain is going, but we can clone and add. Equals visited dot copy dot add starting from. Okay. Hopefully that's not too confusing or inefficient. And I'll just not recurse any further in this case. Okay. That's fair. That's fair. Alright, so I do need to have some way of getting all possible positions. I'm going to make a board split cache. Split of board. And that's going to be board.split n. All positions set I can tell that I need to do some sort of flat map thing here. Alright, for line in split of board, okay. Positions.update. Okay. X, Y for enumerate. This may not actually be a very good performance win, but I'm curious to see how it's going to turn out. So we're going to go through all the lines of the board, get the Y in the line. Alright, and for X in range, len, line. So this is definitely more naive than it used to be. Alright. In all positions. Okay. So yeah, there we go. So that's now covered by this. Range. Y line in enumerate. For X char in enumerate line. Oh, my brain completely got on just. I autopiloted that and it made no sense. Okay. 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 Let's see. Arguments of type none type is not iterable. Alright, so visited. Ah, okay. Yeah, this is the same issue I had earlier with the set API. The good news is if this is different from the other one in terms of outcome, this will catch it. I'm not super happy with this implementation for a couple reasons, but we'll see how it goes. Golang it sort of it depends on what you mean. I'm a little. This benchmark feels like it's running long enough that it's probably not going to be a winner. Yeah, that's so much worse. It's so much worse. And I have to wonder where it's spending the most time. But like, this isn't good. That's worth factoring out. Yeah. God, it's been a while since I've used Go. I used to really love it. So I'm not super happy with this implementation. It's got several ways in which it's just not gonna be very performant because of all the work it's doing that's not necessary. I think that I like that we're checking this here and not recursing in cases where it doesn't make sense to recurse. That I think is like the main saving grace of this being a plausible implementation at all. But index board is probably not very efficient. And it was like the main thing that I wanted to factor out here. So maybe rather than try to fix this in different like permutations, I'm probably just going to make a new approach that is from scratch and more open to being different. I want to think very hard from the ground up about how to build this around cacheable detections. Like, I'm pretty sure that this is just a lot of the problem right here. We're doing the same sort of work in a couple different places where we had it a bit more like pre-computed and reused before. And yeah, I think that's the issue. Be right back. Okay. Hmm. Thank you. So, I think this create mapping construct is good I want to use that. This line, I think, is a lot of the performance difference because we're excluding spaces. Things are only present there if they absolutely have to be. What I kind of want to go for is a graph theory approach. So, from a hypothetical root node with no character, you can move to any valid character in the board. And from any valid character in the board, you can move to its valid neighbors. That network can be pre-computed and reused. So I think that's the direction I want to go here. So, like this, but different. So the graph is going to be a dictionary. I'm just doing this to the data type in my head here. This is very pseudocode. And it'll be just a bunch of adjacencies. Like 1, 2, A. So each of these items here is going to be an X, a Y, and the character it represents. Given that, whatever position you're on, because other than the root, these will all have like an XY position tuple key. Each of these is going to just be a neighbor list that's pre-computed up front. And that allows the visited set approach to work. Rather than a set, I don't know. I have options when it comes to representing what's been visited before. So, board to network. this will need to have a root node, and we can maybe just use none for the root node. I always get slightly paralyzed by multiple valid ways to express something. I just kind of like freeze up, I get non-entertaining while I go over a couple different options in my head. So I'm going to maybe make a variable name for the root stuff. We're planning at the high level here. Mark equals none root. And the reason why I want to do that is because then I can use this as a list of all the valid positions. Oh. Yeah, I like this. So this will actually be an array. I'll do this to build it rather than in a list comprehension. Root dot append, I think it is. I never remember, it's append or push. It's append. Alright, so x, y, char. That is our little type for each entry in here. And then for x, y, char in root, I don't think we're going to need char here, but now we start needing to build out our adjacencies. Yeah, we don't need char here. Okay. So network XY is going to be a list comprehension. Item for item in root if I'm just going to filter this. Here's where we do our adjacency testing. How to write this? Maybe just make a function for it. If adjacent, And we have two different types of x and y here. So item for item in root if adjacent item x, y. Okay, and now I can make a little function here. So this is more setup territory than any other approach so far, but it's going to be completely reusable setup that makes the actual solve loop really fast. Alright, given an item and an x and a y to see if it's within that range, ix iy underscore equals item. We unpack this. Alright, so ABS is a function, right? Yes. Alright. Dx dy equals x minus ix, y minus iy. So these are differences. Absolute of dx equals 0 and absolute of dy equals 1. Or absolute of dx equals 1 and absolute of dy equals 0. So this will detect if the item is an exact vertical or diagonal move. Or not, vertical or horizontal. Not diagonal, I meant to say. Alright, so there's our adjacency test. Now we have a network. Lots of phone calls from people that don't have any business with my time today. And no reason to be bothering me, but they are. Like, I know what each of these calls is. And the answer is no thank you. Alright, so we have our network here. So I'm going to make an explore function that takes a network as the first argument, a word as the second argument, which is kind of like the remaining concept. I could call it remaining, but I'm going to call it word, because I think that I can make this recursive in itself rather than being an entry point to an internal recursion system. Alright, visited equals set. And from equals none, which means start from root, and we've not visited anything yet. So explore with just network and word will be the entry point to the recursion. That will be exactly what it needs to be. And when it calls itself, it will provide these optional arguments with something a little more appropriate. Okay. Return any explore network always got a couple layers of abstraction in my head at the same time. If word equals blank, return true. I need to focus on what the actual iteration is first. Alright, for this takes a network, so it can't be the entry point. I'm realizing that. Anyways, for arrow in network, given start from. So we start from root. We look at all the arrows in there. If let's unpack this. X, Y, Z. No, X, Y, C. Character. If C equals word 0. And X, Y not in visited. Okay. So I gotta get the depth, plunging in deeper, right? This is not right quite yet. But we're going from a starting point, and we are filtering those neighbors by, we already know that they're neighbors, we are further filtering them by if they are the right next letter, and we haven't visited them yet. So how do we follow the arrow? X, Y is going to be our new starting point, and visited equals visited union set. I'm going to pull that out because it's, once again, it's going to be common. Okay. Next, visited equals visited union set start from. Alright, so we do that calculation once. start from equals there. Okay. Now finally we need the last level of, what's it called? Board contains. Board contains board stir. Word stir. And this is going to just be return explore board to network board, which is cached, and word, and everything else is default. So does this work? Here's where tests have us covered. This is why I felt safe doing a more dramatic change. Okay. X and WE should definitely work. Okay. We need to diagnose why that's not working. And yeah, quite a bit of stuff here. Honestly, a bit hard to read. Instead of visited being a set, I'm going to make it a tuple. And that way it's going to be chronological and it's going to be easier for testing, and it might be faster. Alright. Visited start from. Unfortunately, I don't have much access to the cryptic French culture stuff myself. I kind of wish. I took a year of French when I was in high school. And that's most of my exposure to French culture. Not all, but most. Okay. Okay. So we go to 5-2. And then to 7-5. Oh, it tried the two places. Okay. There's probably two X's at those positions, I would imagine. Yeah, 5-2 is an X. The other one is 7-5. It's gonna be down here somewhere, I'm sure. Oh no, here's the end of the root stuff. 7-5 X. Alright, and I think that there's only two X's in the entire board here. There are. So it can get to there, but can't progress further. It's a character in an extremely purposely stupid movie who throws up when he's happy. And right now I'm very happy. So every time a program throws 10 tons of log at me, I'm like, Oh, look, he's very happy. Okay, that's very funny to me. That sounds like French Dumb and Dumber. And I have no idea how accurate that analogy is. Believe it or not, I only saw Dumb and Dumber all the way through this month. I had never seen the whole thing through before in my life until this month. And it's very much something that was like part of the culture that I missed out on when it was, when it first came out. All the kids at school were quoting it, but my parents were a little too strict to let me watch it. Nice. I feel like that would be like a very memorable running joke, little running gag. It does. Okay. So, what was the output again? We get none, 5-2, we get none, 7-5. Okay. And that's here, where we're starting from an X. So this has to be not right, somehow. I'm going to increase the debug output so we can see the adjacencies. The first X is adjacent to a K and a W, and the second X is adjacent to a D. So I think the adjacent function is where the issue is. Oh yeah, this has to be wrong, and I'll tell you why. So we're starting from here. This is the start from, and here's the stuff that might be the next step. This one is a neighbor, definitely. But this one, this is a flying leap. Look at this. 5-2 to 5-4. That's a flying leap, so the adjacent function is wrong. Okay. So, what I'm going to do here is return ix, iy in, and I'm going to make a list of things that are actually neighbors to xy. Oh god, I think I fixed it, but now there's all the debug printing in it. Okay. Turn that off. Huh! So much happiness indeed. Property testing went pretty fast on that. It's always going to be as slow as doing that many iterations of the reference implementation. Holy fuck! excuse me. I'm I'm trying to keep this stream a bit less profane than I sometimes am, and I let it out. I let it out. But God, look at that. 9 seconds. That is the power of pre-compute so that your inner loop can be fast. 9 seconds, and it's really elegant, honestly. That is so cool. That is so cool. Yeah, this is a really elegant solution, and it's hard for me to think about like what I would rather do to make this better. Because we have a few things going for this that some of the other implementations don't. All of the heavy work has been moved into something that is LRU cacheable. So we do it once, and then never again. Like, all this stuff, it doesn't actually have to be that fast. This has to be fast. But that's it. Furthermore, we are actually skipping recursing into things and calling functions in a lot of cases. We're just not doing it. Like, this is doing a lot of the filtering before we call a recursion of Explorer. But so is this. Like, this is the upfront work carrying us pretty hard. Because we're able to get a list of neighbors that has already been completely filtered down. So I'm quite happy with that. And the only part of this that like is kind of a wasted like, oh, did you really have to recurse into that? Is this check at the start. And I'm not entirely sure what I would do to remove that and move it more into like this kind of thing. Maybe like, oh, I know what I could do. Word equals C or. Okay. I think that this will also be valid, but it will be faster by the tiniest of margins. So without needing to have a recursive function call, we know what that next letter is that we've got from the arrow metadata in the graph. So without even recursing yet, we check, is word, all that we've got left, just that character? And if it is, we early out. So I don't know if there's a syntax issue that'll require me to wrap these in parentheses. Looks like it. Maybe. Okay. I think there's a way to do it. I'm once again going to listen to my body and use the bathroom to get more coffee. But then I think there's a way to get this last little needless function call out of the way. I think I have a plan, or at least I might. Let me rebel something real quick, 'cause you never know until you check. And the rebel is really good at this. Really good for this. All right, X, Y, Z. All right. That does that. All right. The next thing I'll do after this is I'll put my code up. Okay? I like your approach. Okay, that didn't actually help. I mean, taking recursive things and doing them as just flat iteration instead can be very efficient. And I should make an implementation like that too while we're at it, because that's a very good idea. So technically, what I just did here, I made it work because the behavior of this instead of indexing 0 gets the dynamism that I needed to do the right thing in different cases. But it's less clear code, and it's slightly slower. So this is what I'll call the final form for graph.py. All right. So what I want to do here is I want to make a markdown document of this. I have a thing on my website where I can have a markdown document full of code and have that easily downloadable as a directory. It's a project called Glue that I worked on a while ago, and this would be a good opportunity to use that. So I'm going to do that at some point today. I need to budget myself time here. I've got an hour left. So this is going to be, what am I going to call this? Word search in python.md. I think this is the convention I've been using. I want to make sure it's consistent. Oh, underscores. Okay. And I need to save myself a little time for some final stuff that I wanted to do. It's a little less, digging into code itself. A little more metatextual and state of the world kind of thing. But Vault, this is software, practice, and word search in python.md. Okay. All of these examples rely on a suite of common tools for testing and benchmarking. I'm going to just make sure that this has got the files in it, because I want you to be able to verify this yourself. Do your own performance testing. So what's the thing? Is that it? Yes. Okay. This is the reference implementation known to be correct. Easy to verify with manual tests. The property tests against itself are a bit silly and tautological. It gives us a performance and correctness baseline. Compare other options. takes about 24 seconds on my machine. I have to put these file names in here because the markdown to directory thing that I've written relies on those. This can be improved a bit further by memoizing some upfront work about specifically the construction of pose to chart. Yeah. I think that I need to add Python as a supported language real quick because different languages have different comment syntax, which is like the main like scaling difficulty. Is I need to support a bunch of different comment syntaxes. I have Rust, Python, I think Makefile support. And you can actually see, like, this is... I might need to just call this Python instead of Python 3. The fact that this is not syntax highlighting is not a great sign because Obsidian and My Software Glue are trying to be compatible with language indicators on here. Both looking at Prism.js as the upstream thing we're trying to be compatible with. Obsidian is like this major note-taking app. They're not paying attention to me, but they're paying attention to Prism.js, and so I pay attention to Prism.js. Alright, so now we have syntax highlighting. That's a good sign. That means it probably will be working on my website. I need to add it to that list. Wordsearch in Python. Site, or no, software practice, Wordsearch in Python. Okay, so now if I look at my website and I refresh, oh, I know why, because there's privacy filtering of the stuff in here. Here we go. Okay, so I need to have my front matter, title, word search in Python. Don't know why I always accidentally type a G there. I feel like it gives away some accent stuff I'm trying to not fall into. Alright. And now my website will willingly display this. And this is my public website. You can go see this for yourself. I will add the glue support here. I think that's the syntax. Alright, so I'm going to have 3 reference.py. You know what? It's always good to have a bash in there. So if I refresh this, here we go. So that copied that to clipboard. I'm going to try that out. And it did not detect the file name. Okay. So that means I need to add Python support. Okay. Amazing that I hadn't done this already. PQR, yes. Okay, Python. Python. I would also like to do the right thing if someone says Python 3 in the language tag. And honestly, even just Pi. So we have a couple friendly synonyms that all point to the same thing. So no need to test that. It's covered by round trip, and Python is going to be starting with a tick mark, and that's probably it. I'll just add a test, and either it works or it doesn't. If it doesn't, I know I need to poke around. Yeah, wow. Yeah, copy and paste always works. It always works. Okay. I tapped the wrong thing. That's okay. Most of this work will be reused for compiling the test version. Oh! Well, oh. There we go. Alright. Run tests. And the Python test succeeded. Okay! So, and today is 7/26.